Right now, I will try to give you an introduction to Numpy. It won't be as comprehensive as the pandas one because you might not actually need that much of Numpy initially. You will need it later on when you are a little more practiced, when you have done a little more practice, but it's important and it will make your journey a little more easier if you know the basic syntax of NumPy. At the end of it, I have one challenge per se for everyone who's here. It will take a little while and you will have to use everything you have learned so far, but more on that later. If you manage to do it properly, I will give you my email at the end of this. Send me the answers to the question which I asked. I will give you a data set, build something like the Titanic one, which I have been talking about. You will have to use NumPy and pandas to do some analysis on it. Um, Whoever I find has done the best work, I will give you a chance to call me personally and maybe clear out other doubts you have in other stuff like data science, maybe machine learning, or if you have done anything of deep learning, something about that stuff. Okay, let's talk about that later. For now, NumPy. What's NumPy and maybe why should we use it? The good thing and probably the bad thing about Python is that it's slow. So if I have a list, say just 1, 100, the same thing in NumPy, very simply, is just numpy.arrayofl. That's it. That's the only syntax you need to convert a list from the normal Python list to NumPy array. But why? That's the question. Why? Um, just very simply is that this list is very slow. If you're doing something like data science on a few thousand rows, that's fine. But if you have a million rows, or maybe later, if you're working with a huge data set of maybe 20 GB or something, and if you're just using lists for it, or just the normal pandas series for it, it might be slow. So we go with NumPy because at a later stage, what NumPy does is that it allows you to work with a GPU. So if you have a gaming laptop, you will have a GPU, and um, the advantage of it is that if you have a very long array. So for example, if you have, I have written down something here. Yeah, if you have an array from 1 to 100, and this is a small syntax, I will show you what it does. A range. So remember the shift tab thing, and you can see what it does. Evenly spaced values within a given interval. So basically all I'm saying is that give me numbers from 1 to 100, or 0 to 100 for this matter, or 99 because it's a range. If I want from 1 to 100, then maybe 100 more. Yeah, 1 to 100. If I want, I can add a step as well. So it'll give me all numbers from 1 to 100 with a small range. So 1, 1.2, and so on. So if you see, this is so much easier than writing a for loop. So if you're just starting off with Python, you might have done it this way. You might have, say, made this array for I in range. Maybe I'll just take the same thing. I in range, the same thing. Then you would do L dot append I. So you, if you've just started with it, this is the way you're probably used to. And this is cool. It works out. Maybe initially it's fine. And but for large lists, for something like maybe if this was a million instead of 101, or even if it's more than 10,000, say, using a list is not a very great idea because it's slower. And if you have a GPU, I have a gaming laptop, so I have a GPU. It will be much faster for you to do the same computation using a NumPy array than a list. And plus, as I'll show you as I go along, there are many things which you can do very easily without having to write anything extra. So for example, this thing for I in range L dot append I. All I'm doing with this is that I write it A range. Okay. There are different ways of getting this done in one line. One of them is called list comprehension. Why I want to talk about list comprehension is because it's very handy. It's maybe not something people would talk about a lot, but after a point, you'll find that this makes your coding experience a lot easier. And plus, it's very easy to get these NumPy arrays very fast with this. So for example, I take the same loop. So I take my for loop here, I put it here. But instead of just making an array, I want to do something else. So I say want to add the square of it. Say. I mean, I know you can do the same thing with a range, but just as an example, suppose I want to add I square to L. So if I just do this, that's fine. It'll still give me a value. Oh, my bad. Yeah. So it'll still give me a value. That's fine. But the problem is this particular thing, I cannot parallelize it. So the major difference between NumPy and just a normal Python list is that right now, if I am adding this list, each of these things are being done one at a time. So this is being sent to your system. It's computing it, adding it, and so on. But if you're doing the same thing with NumPy, it parallelizes it. So it does say a batch of these things, maybe as an example, this is not the accurate number, but as an example, it will do 10 of these things at once. So it's called a thread. If you have done operating systems, you will know about threads. If not, that's fine. Just get the intuition that it's faster, way faster. So people generally stick to NumPy. But if you want to put all this in one line, there's something called list comprehension. So I will just write it down. List comprehension. Uh, Maybe search about this. Oh, no, sorry. Maybe search about this later because it will come in handy. But just to show you guys an example, all I'm doing, and the syntax might look confusing, but I'll explain it. So no issues on that. So it's almost the same thing. So all I'm doing is this, and if I copy paste it here, and this is X. So if you see, it's giving me the same thing. But if I want to add this bit, all I do is I just change this, same thing. If I want to add something else, same thing. I'm not, if you see, there's not much difference from this to this, unless I add something else. So if you see this, if I had to do it using the normal syntax, it would be another line and so on. I can add if else statements and everything here, but I don't want to go into that bit. You can search for it later if you want. Why this is useful is because right now here you have to initialize one data structure, and this itself will take time because you're not using NumPy. But when you're doing this particular bit can be performed parallelly. So it'll be faster. Maybe it's not useful for a small example, but later you might come across computations where just using a normal for loop is taking too much time. Plus, if I want to convert this into an array, I can just extend this. I can just write this, and now I have a NumPy array. Okay, so it might look confusing at first. So let me break it down a bit. I'm not doing anything new here, but all I'm doing is rearranging things. So for, this is my for part, which is the same as this. It's the same thing. But all I'm doing is saying that some value, okay, let's just take it as X to make it easier. Let's just take this as X for now. So some value for this in range. So if you want to use I, you can use I, but then you'll have to change all of this to I. The whole point is that you're making this in one line. And now this list, while it's being made, it can be parallelized. So initializing this will be faster than you doing a for loop. Now I can maybe show it to you, but it might not give me a very huge boost because I again have a gaming laptop. But yeah, so if you see for me, it's still smaller. It's in new seconds. But if you still see the difference, okay, so this is something called a cell magic. Again, lots of syntax, you don't need to think about it. All it does is tell me how much time it took for me to execute this, just this cell. It's useful for situations like this where you want to see which and what is doing better. So right now, just by looking at the time, so if I see um, this took me 5.25, but just using a numpy array is 4.77. And this is just a very tiny array. So imagine the difference when you're using a very large array. So if you can see just by this much, it's much better to use list comprehension than put a for loop. It's faster. Again, if you have a little slower laptop, you might notice the difference between these two is much larger than mine. But that's fine. That's You might want to use an online thing, which I'll show you at the end of this. Okay. So another thing which is really cool about NumPy is that it allows you to perform some calculations on it very easily. So if I want to say find the sum of this array, so let's just set this to a variable. So if I have temp as this array, again, it's the same thing. I haven't changed anything. This is my temp. If I want to find out the sum of this, you can again do it using NumPy. So I have imported NumPy as NP. It's just a short form. So I could just do import NumPy, but then every time I run a NumPy command, I would have had to type NumPy dot something. So instead of that, I'm doing it as NP. Maybe look at this syntax a bit, because when you have a lot of libraries and stuff you're importing, it's just easier if it's in like 2 letters instead of the whole word. So what I want to do right now is maybe find the sum of this. So I just do np.sum of temp. That's it. That's my sum. Nothing doing, just one word. And if I want to find the, I don't know, maybe something else. Let's see. Dot, dot. Okay. So this is called a matrix product. And if you have done a little bit of vectors and stuff in college, then maybe you will know about it. All I'm doing, I'll show you how this works later. But the whole point is, again, any syntax you've forgotten what it does or why it does what it does, just click shift tab simultaneously. It will give you the docs. So it'll tell you what it does and show you an example of it as well. I'll come back to np.dot later, but just as an example. Okay, have you guys heard of standard deviation? Standard deviation. This has a pretty long formula, and if you want to just do it manually, it might take you a little more effort because you'll have to first find the formula and all that. Okay, in the comments, tell me how you think you can do this in the NumPy syntax. It'll be the same thing almost. Maybe you'll just have to replace something in this. So tell me how you think we can convert this to a standard deviation example. I will give you a few seconds. You can take a guess, it's fine. I mean, nothing wrong or right. Okay, cool. Aryan has given me the right answer, and so has Shubham. np.std of temp. So if you see, it's really easy. It's extremely easy to do any kind of numerical computation using this. Um, Another thing which is really easy and cool about NumPy is, let me show you. So suppose we have this as temp. So I will keep these things. But if we take the same array, temp, and now what I want to do is I want to add something to every element in this. So I want 11 to be 12, 12 to be 13, say, just as an example. How would you normally do it? You would probably put a for loop. But again, as we have managed to, oh, I managed to quit my note. Give it a sec while it loads. Um, I quit it once. So yeah. So if we take temp again, and right now I want to perform one, I just want to add one to every element. And how you would normally do it is that maybe go through a for loop. But as we have proved it here, it takes more time and you don't want to do that. So the same thing in NumPy is very simple. I just write temp plus one. And if you see, it's done this for every element. Every single element here has had this one operation. Likewise, if you see, this is extremely useful. I mean, if you want to perform something for your whole data. So let's take the previous example which we were working on, something from the Titanic. Okay, let's just take this, df.p class. So we have this. If you want to get this to a NumPy array, we have to do dot values. So right now it's a NumPy array. So just one syntax. So all it's doing is that it's taking my whole column and putting it into an array. For the same thing, okay, let's make this temp2 and maybe, yeah. So if you want to perform anything from here, now remember this is part of our data analysis. So if you see, it becomes extremely easy if I just want to do a sum of this. Honestly, doing a sum here makes no sense, but just as an example. Likewise, if I want to say add a constant number, or if I say want to multiply this whole thing by a number, or do anything for that matter. If you see, I don't have to write a loop. Okay, someone's asking me about reshape. Reshape is another useful command. You might not encounter it that much while you're doing data science, but the whole point is that if you have an array, so if you remember, I had talked about dot shape. So dot shape would give me the rows and columns, because this is just one whole subset or one column. We don't have a second value to this. But if we create another array, so if we have another array, say, I will put a few values, 1, 3, 4, and maybe I put 1, comma 4, say. Oh. So I'm taking a list and I'm making it into an array right now. If you see, this isn't going to work very well. But what you can do is you can use something of NumPy's. I have written it down somewhere here. Yeah, you can use this. So all it's doing is that if I want a random array, as an example, because it makes no sense to have reshape for our data set. So let's just take a random value. So all I'm doing right now is I'm making a matrix. So if you see, it's the same thing. It's just an array with 3 columns and 2 rows. Now, why I would need reshape is that sometimes I might want this to be in a different dimension. So say I'm add one more. Right now I have, this is my shape of my array, or if my matrix, if you want to call it that. Right now it's a 3-dimensional matrix or a 3-dimensional array. And if I want this to be in a specific shape, you might not really need it here, but if you ever do encounter a situation where you want to change the shape of your array, okay, let's just call this temp3 as an example. Yeah, and if you want to change this into something else, so remember that sometimes you might maybe want the transpose of this. Transpose is basically I convert all the rows to columns and columns to rows. Um, Before I get to reshape, let me show you what I'm trying to do. Suppose I want the transpose of this. NumPy has a very nice and convenient thing called .p. So this will give me the transpose. If you see, all I've done is converted the rows to columns and columns to rows. Why I'm using this is just to print. So it doesn't really have any value, but if I remove that, it won't print it. You don't need to do the semicolon thing. You can just put it in a new line. Since I'm using Jupyter Notebook, I don't need to write a print statement after everything, it would still do the same thing. Jupyter Notebook has a nice property of printing out whatever you have written at the last of every cell. I'm using a semicolon because it looks nice, and I'm used to having things on one line. It's not really imperative. You don't need to write it. You can, if you want, you can just print it somewhere else. So, yeah, I hope that answers the question. Okay, so if I'm talking about reshape, this small thing will give me the transpose. But if I want to do reshape, let's just have a look at the documentation and see what they say. Shift tab. So all it says that it will take the same data and give it a new shape. As I was saying, if I don't want 2 comma 3 comma 1, if I want in some other shape, so say I put -1 comma 4 comma 1, you see that this won't work. Why -1? Very simply because I don't want to calculate it. If you know which shape you want to get this in, you can do it on your own. So if I say I want to make it 3 comma 2, so, and I don't want it to be in 3. If you see, this is reshaped it to 3 comma 2. If I do the shape of this, it's 3 comma 2. If I do the shape of temp 3 initially, you'll see it's 2 comma 3 comma 1. So this is useful generally if you're working with images. So your any image which you read would be in the form of an array. I can show you an example. I'll show you an example towards the end maybe, but you won't need that right now. Generally, you would use reshape if you are working with a data set such as maybe even Titanic, and towards the end, when you're trying to run one of the algorithms such as say sklearn, something from sklearn, um, it might show you that you are using just one column. So it might be getting a little complicated for many of you. So let me explain it again. Suppose I just have one array, just one list. So it's basically one column. But okay, let's just take this as an array. Let's take the one which we're using, temp, right? If I do the shape of temp, it's just 90 comma, right? But if I need a two-dimensional array, so sometimes your algorithms might require a two-dimensional array, so 90 comma something. Over there, I might want to reshape. So I might want to say put -1 comma 90. Uh, Again, it's the same thing. It's the same thing. If I do temp dot shape, okay, it might get overcomplicated. But the point is, right now, if you see there's two brackets, which means right now it's a two-dimensional array. It's 1 comma 90. Why is it -1? I mean, I could just as well put 1. That's fine. But then for a bigger thing, you would need to calculate the value of this separately or manually. Instead of that, you can just let Numpy do it for you. So if I take something like 30 comma 3, this I would have had to calculate manually otherwise. I know it's going to be 1, but anyway. If you want to know how the calculation is done, it's very simple. It's extremely simple. All I have to do is I have to keep this constant. So suppose I do temp.shape. I know this is 90. So you can ignore -1 because it's being calculated automatically. Generally it's 1. Like if I reshape it, I get this is 1. So all I have to do is make sure that the product of all of these three is the same as this. That's how it's calculated. But I mean, we're lazy as programmers, so got to put a -1. Okay, moving on. Another very useful thing in NumPy is something called a identity matrix. So if you have heard of this term before, that's cool. If not, all it is that it's a matrix. Suppose I take this as an example, but it should be okay. I will repeat the -1 thing again, but let me finish this bit. So if I want a matrix where my columns are 1, so just this, have a look at this. My diagonals are 1 and everything else is 0. This is called an identity matrix. It's useful because in many formulas you might have to use it. So if you've worked with matrices, you might have seen this thing A star I plus A, something like that. So if A is a matrix, I is your identity matrix. A could be literally anything. So it's a very easy way in NumPy to make an identity matrix. I will tell you why we do this. Um, but before that, I guess some people have questions about the -1 thing. So let me repeat that once more, then I'll get back to this. While I'm doing a reshape, so let's just do it again. But while I'm doing a reshape of, let's take the previous thing. Let's take temp since we were working with it. So this is what we have. We have temp, right? Um, we also have the shape of temp, which is 90. Now, if I want to reshape this to some other value, so say I want to reshape it to 2 comma 30 comma something. Now, generally, you would have to calculate this something. In this case, if I put -1, you'll see that it says I can't do it because, I mean, this is already 60 and you can't multiply this by a real number without it being a decimal to get 90, right? So the whole point of using -1 is that you don't need to do the calculation on your own. It's very simple, nothing much to use it. It can automatically infer any one dimension. So if I want to make it into some other dimension, say I take 3, 10, comma 3 again. If you see, I don't have to write the last element. Similarly, if I make this 3, I can make this 1. And if you see, this is not going to work because this particular array cannot be reshaped into any sort of value like this. This is mostly, again, not very required, but just so you know what reshape does. Again, if you see this, it'll work. Why it didn't work? It's because of the matrix. You have to do the calculation on your own. Again, that's why you can just use -1. It'll save time. And it's just easier and you don't have to do any work for it. Lastly, okay, Zoom is running out of it again. The last thing I have left before I move on to the challenge is this. So if I want to check for a condition throughout the array, so remember the part where I used to do temp plus 1 and gives me. Likewise, I can also do temp greater than, say, 10. So maybe let's take 5. So if you see, all my values in temp should be greater than 5. That's already there. How about let's take temp greater than 15. So if you see, the first few are not greater than 15. Yeah. So just as an example, this is how it works. Why it's useful is because you can add more operations to it. So you can, I have tried to make an example here. Yeah. So suppose I take a random thing here. So as an example, this is what it does. It gives me a random 4x4 array. And if I run it again, it'll give me a different one because I haven't saved the variable and it's a random one. But the whole point is if I want to check one condition throughout it, I can do this. I can do greater than or less than or whatever. If you see, you can use this directly in the Titanic thing, which we were talking about. So if I take, say, df of p class, maybe p class, and here if I do greater than 1, so if you see, it will automatically tell me whichever other one's greater than 1. And you can use this to plot stuff like I had shown you before. So the pandas library also uses NumPy. So it's just easier if you know the NumPy syntax, then you can relate it to stuff in pandas. Okay, that's it for a NumPy introduction. I've mostly covered everything you need. Okay, NumPy slicing in greater rank arrays, I actually don't want to show it to you right now. So if you have that question, message me later, I'll explain it because it's a little complicated. And if I show you everything in one go, you're just going to get confused. Divyam, just drop me a message later, I'll explain it to you. Okay, now before the thing ends, let me explain the competition. Okay, so this is one data set. I will send it to you, no issues. I'm not going to explain anything about this. Have a look, read it. Um, and my question is that you have to perform as much as data analysis as you can on just this one data set. So if you see this has 129 columns, again, I'm not expecting you to go through every column. So take the first, say, 20 columns from this, the first 20 columns from this, and extract as much as data as you can. The challenge more specifically is you might find that many of these are text. So you will have to find out how to handle them, because you can't just use Numpy directly because these are not numbers. Anyway, that's very easy. The point is I want to see how much analysis you can do on just the first 20 columns. It's a not a very large data set. And yeah, I will give you my email. Um, I'm putting it in the chat. Just copy, paste it, and keep. Okay, that's my email. Copy paste it, or if you want, I will write it down here. Just take a screenshot, or maybe I'll just send it to you. I don't really want to post it on the group because people will get confused. Anyway, um, take a screenshot of this or write it down somewhere. I'll keep the screen on for a while. The whole point is try to identify this, try to do as much as analysis, maybe using the stuff, hopefully using the stuff you've learned today. If you can do more, that's great. But try not to take the answers from somewhere else. I mean, you can do it just as easily, but you're not going to learn anything from it. And it's really not worth it. So I will send you this notebook, the one I've taught today. I'll send you the link to this. Have a look at this, maybe use the same things, but try to mess around, try to play around with it and see what else you can add to it. Okay, great. I'm done for today. I will send you guys this link on the group. Refrain from posting anything, any answers and stuff on the group. If you have any questions, you can message me separately. I will reply. Any questions so far from the Numpy part of it? Okay, cool. Thank you. I will send you the content of today's and this question. Try to give me an answer by tomorrow or day after. Nothing strict about that. Yeah, I will post a link to the data set on the WhatsApp group. Don't worry about that. And also this notebook, so you can brush up on whatever I've covered so far. Fine, guys. Thank you. I hope you got a good introduction. This is not the end of it all. There's a lot of stuff left. It's just starting out. But once you go through this, and I would advise everyone to do this challenge, just take the first 20 rows and apply whatever you've learned. Trust me, it'll help you a lot, and it'll give you a lot of what do you say, experience to handle other relatively more complicated stuff from this part, from the whole data analysis part. Fine, guys. Thank you. Yeah, I'm gonna end the meeting now.